Hello, ladies and gentlemen. We're going to take another step down one-step equation lane by discussing how to solve one-step equations using multiplication and division. Just as a review, one-step equations, the way we solve them is very simple. We try and isolate x on the left-hand side of our equation, or we isolate the variable, whatever our variable is. We do that by moving all of the numbers to the other side of the equation. We move numbers by using inverse operations. And inverse operations are just opposite operations. For example, if I saw addition, just a moment, ladies and gentlemen, if I saw addition, the opposite operation would be subtraction. These are inverses of each other. In this lesson, you're not going to see any addition or subtraction. Instead, you're going to see multiplication and division. But the concept is the same. Multiplication is the inverse of division, and division is the inverse of multiplication. So let me show you what I mean by that. We've got 3 multiplication and 2 division problems, left and right. I have 10 times x equals 80. Well, since I see multiplication, I'm going to use the inverse of multiplication, which is division. And I'll divide both sides by 10. Divided by 10. Let me make that a little neater. Divided by 10. 10 divided by 10 is just 1. And I'll drop down that x. So I get 1 times x is equal to 80 divided by 10, which is just 8. Well, 1 times any number is just itself. So 1 times x is really just saying x. And so my answer is x equals 8. And if you don't believe me, I dare you to try it out. Plug it in. 10 times 8. Does that equal 80? Yes, it does. So it's really the same as before, except instead of adding and subtracting, we're using multiplication and division. Let's do another one. Right here, I have 3x equals 15. That's really saying 3 times x equals 15. Well, the inverse of multiplication is, again, division. So I'm going to divide both sides by 3. Once I do that, 3 divided by 3 is 1x. And 15 divided by 3 is 5. So I end up getting the equation 1x equals 5. Well, 1 times x is just x. So really, I'm just saying x equals 5. And look, our variables are isolated. There's no numbers next to them. It's just the number on the right-hand side, the variable on the left-hand side. And again, if you don't believe it, plug it in. Be sure. 3 times 5. Does that equal 15? Yes, it does. Here's another one. 9x equals negative 36. Well, this is 9 times x. So it should be no surprise when you see me use division right now. I'm going to divide both sides by 9. 9 divided by 9 is just 1. 1x. Negative 36 divided by 9 is negative 4. And so my answer is x equals negative 4. And I dare you, try it out if you don't believe me. 9 times negative 4. Plug it into a calculator if you have to. Does that equal negative 36? It does. Because my variable has been isolated correctly, I get the right answer. Okay, Mr. Grab. I think I can see multiplication use division pretty easily. But what about this division business? Are there any differences? Well, no. Just take a look at these two right here. But hold on, Mr. Grab, I don't see division. I see a fraction. What do you mean division? Well, that is division. Fraction lines represent division. Because after all, fractions are just taking a large number, a larger number, I should say, and dividing it into smaller pieces. Fractions are division. So this isn't just x over 6. This is x divided by 6. And if I see division, what do? You guessed it, multiplication. I'm going to multiply both sides by 6. Well, 6 times the top part of the fraction is just 6x over 6. And 4 times 6 is just 24. So I get the equation now. 6 times x over 6 becomes 6x over 6 equals 24. And now I simplify. Well, 6 over 6 is just 1, right? So this is really saying 1x equals 24. And 1 times x is really just x. And so I get x equals 24. Let me break that down, just for some of us who might be a little wary of that. What do you mean 6 over 6x it just becomes x? Well, let's think about this. 6x over 6. Well, 6x over 6, I can simplify 6 over 6. 6 over 6 becomes 1 over 1, right? Or rather 1x over 1. I'm simplifying. 6 over 6, the fraction, becomes 1 over 1. And 1 over 1 is really just 1, right? So 6x over 6 is really just 1 times x. X equals 24. Let's do another one, just to be safe. I have x over, well, I've got negative x over 2 equals 5. This is division. I see division. That's what the fraction line represents. So I'm going to multiply. Without a second's notice, I'm going to multiply right now. And I'm going to multiply by 2. But let's be careful here. Because not only is this a 2, this whole fraction is negative. I'm going to multiply by a negative 2 to make sure that when I end my answer, my x is positive. So negative 2 times negative x over 2 becomes a positive 2x over 2. 5 times negative 2 equals negative 10. As discussed before, 2x over 2, essentially these things cancel each other out, and I'm left with just an x equals negative 10. And that's my answer, folks. So look, one-step equations using multiplication and divisions are the same as one-step equations using addition and subtraction. When you see a one-step equation, the only thing you need to do is determine, is my number being added to my x, subtracted from my x, multiplied to my x, or is my x being divided by that number? Once you determine which of the 4 operations is being used in the equation, simply use the inverse of that operation to move the number over. Once you do that, you'll have x alone on one side and the answer on the other. I encourage you, please rewatch the last 2 videos and maybe, this is just a suggestion, practice with the questions on the videos before I solve them. See if you get the same answers. And if you need more practice, you can always check out Google Classroom and practice with the homework problems. Please, if any of this is still uncertain after all of that, come see me so that I can help massage those concerns away with my words and my intelligence. This analogy kind of got out of hand. Let me just massage those and help you understand what to do. Massage your brain is what I was trying to say. Anyways, I'll see you in the next video.